Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Sharda Nagar Baramati. Let's start. Today we learn about the coordination chemistry lecture 2. So in this lecture we see the various terms which is used in the coordination chemistry, and in that some terms are, or mainly in this lecture we see about the various ligands. So here we see what is meant by ligand. So ligand is any atom, ion or molecules which is capable of donating a lone pair of electrons to the central metal atom or ion, that is called as ligand or coordinating groups. Ligand contains a lone pair of electrons, and that lone pair of electron have capacity to donate atoms to the central metal atom. So there are various types of ligands, and that ligands are classified into different types, that is monodentate ligand and polydentate ligand. In polydentate ligand, again depending upon how many donor atoms present in that, they are classified into bidentate ligand, tridentate ligand, tetradentate ligand, pentadentate ligand, and hexadentate ligand. So we see details about this monodentate ligand and polydentate ligands. So firstly, we learn about the monodentate ligand. So in the monodentate ligand, we see the different examples. So monodentate ligand means in that coordinate compound, that donor atom have only one lone pair of electron and which is capable for donating to the central metal atom. So in the coordinate compounds, there are so many such type of monodentate ligands present. So we see some examples of that. One of the example of that monodentate ligand is fluoro. So these different compounds or ions, they are used in simple compound also. And in simple compound, we use its common name. But in the ligand, they have certain other names. And so IUPAC names are given for that ligands. So for the fluorine or fluoride, the name of ligand is fluoro, and it is shown by the F minus. For chloride ion, ligand name is chloro, and its formula is Cl minus. For the bromide ion, its ligand name is bromo, and it is shown by Br minus ion. For the iodine ion, the ligand name is iodo, and its formula is I minus. Then for azo group, ligand name is azido, and its formula is N3 minus. Then cyanide ion. For the cyanide ion, Cn minus ion, ligand name is cyano. So when Cn is attached to the metal and it forms simple compound, then that CN is called as cyanide. But when that CN is present in the coordinate compound and it acts as a ligand, then its name is given by IUPAC method, and that is called as cyano. So its formula is CN minus. Then thiocyanate ion. In thiocyanate ion, that is HCN, sulfur and nitrogen both are donor atoms. But at a time, out of that sulfur, nitrogen and carbon, only one can donate one type. And so, which atom is attached to the metal, depending upon that, point of attachment or bonding is shown. So, in case of the coordination compound, when sulfur is donated to the metal, then that is called as thiocyanato. And in that thiocyanato, S is bonded with the metal and it is shown by the formula SCN minus. In other cases, instead of the sulfur, nitrogen is attached to the central metal atom, that is called as N bonded. And that N bonded compound is shown by NCS minus. And that is called as thiocyanato N. Or they are also called as isothiocyanate. Means here we take the difference between that two very carefully, that when there is HCN and in that HCN sulfuric donor atom, that is called as thiocyanato, and when nitrogen is donor atom, that is called as isothiocyanate. Or they can be given by some other ways, that is thiocyanato S and thiocyanato N. Then hydroxo group, OH minus ion group, that is its ligand name or IUPAC name is hydroxo. Then water molecule or aqua, that aqua, its ligand name is AQUO, AQUO. So here there should be AQUO, not AQUA. There is some printing mistake. And so name of that H2O is AQUO. Then one of the next monodentate ligands is CO. So this CO is neutral ligand, and that CO neutral ligand is called as carbonyl. Aquo is also one of the neutral ligand. So these are the some examples of monodentate ligand. There is also some other examples of monodentate ligand, CS. That CS is called as thiocarbonyl. Then NO plus, it is positively charged ligand, that is called as nitrosyl. Then one of the other ligand, that is NO2 minus. So that NO2 minus, that is called as nitrito N, or they have also called as nitro. So simply this in NO2, here nitrogen and oxygen both are the donor atoms. But when nitrogen is bonded with the metal, then that is called as nitro. And when instead of the nitrogen, oxygen is bonded with metal, then we can write the formula ONO minus. Means here oxygen is bonded with metal, then that is called as nitrito O, or by common name that is called as nitrito. So remember, NO2 minus means nitro group and ONO minus means nitrito ligand. Then CS3CN. That CS3CN, that is called as methyl isocyanide. Methyl isocyanide. Then PR3, that is phosphane. PY, pyridine. NH3, NH3 ligand is one of the neutral ligand and its name is amine, A-M-M-I-N-E. So here, if there is spelling A-M-I-N-E, then that is some other ligands, which is the derivative of ammonia. But when ammonia molecules, then that is called as A-M-M-I-N-E, amine. One of the example of ligand MENH2 and its ligand name is methylamine. Then NH2 minus, NH2 minus its ligand name is amido. So these are the some common examples of monodentate ligand. With this, there are some other ligands, that is the polydentate ligand. And in that polydentate ligand, first is the bidentate ligand. So in bidentate ligand, there are so many examples. In that example, first example is ethylene diamine. So ethylene diamine is denoted by its short form or abbreviations EN, and its formula is NH2CH2CH2NH2. So in this formula, here two nitrogen are the donor atoms. So these two nitrogens attach with the central metal, and so this example is example of bidentate ligand. Again, in the bidentate ligand, there are symmetrical bidentate and unsymmetrical bidentate. So when that bidentate ligand shows symmetry, then that is called as symmetrical bidentate ligand. So if we see this NH2, CH2, CH2, NH2, then there is certain sequence or there is plane of symmetry. And so this is the symmetrical bidentate ligand. Now, second example, 2,2-dipyridyl. So that 2,2-dipyridyl is shown by the symbol DIPY. And this is the structure of this DIPY. So in this DIPY, these two nitrogen atoms are the donor atom, and this is also one of the example of symmetrical bidentate ligand. Now we see the third example, glycine-atto. And glycine-atto is shown by the symbol GLY or by short form GLY, gly. Its formula is NH2CH2 C double bond O minus. In this example, nitrogen and oxygen, these two are the donor atoms. Now, if we see the symmetry of these two, then here one donor atom is nitrogen and other donor atom is oxygen, and both are different. If we see here plane of symmetry or axis of symmetry, then there is also not observed symmetry, and so this is the unsymmetrical bidentate ligand. Now next example is acetyl acetate. So this acetyl acetate is one bidentate ligand. It is shortly denoted as ACAC. And formula of that ACAC is in this way. CH3 C double bond O, CH C CH3 O minus. Now you see here, if we see here again symmetry, then here CH3 C double bond O. At center there is CH. Again CH3 O minus. So here, if we see the symmetry, then we can observe that there is symmetry, but charge on the oxygen atom is not same. Now one of the next bidentate ligand is dimethylglyoxamide, or its short form is DMG. And that DMG has formula CH3C double bond N OH, then here CH3 double bond N O minus. Here two nitrogen atoms are the donor atom. But if we see here symmetry, then one nitrogen is attached by OH while other nitrogen is attached by O minus. And so it not shows any symmetry. So DMG is unsymmetrical bidentate ligand. One of the next example of bidentate ligand is oxalato. So oxalato is shown by the its short form OX, and its formula is in this way, COO. Now this shows symmetry, and so oxalato is the symmetrical bidentate ligand. Now we see some other type, tridentate. So tridentate means in the polydentate ligand there are 3 donor atoms, and these 3 donor atoms donates their lone pair to the central metal atom or ion. That ligand is called as tridentate ligand. So there are some example of tridentate ligand, that is diethylene triamine, or in short it is shown as DIME. Its structure is not shown here. Tetradentate. Tetradentate means in that there are 4 donor atoms or 4 lone pair of electrons are attached directly to the central metal atom or ion. And example of that tetradentate is triethylene tetraamine, or its short form is trine. Then pentadentate. Pentadentate means in that 5 donor atoms or 5 ligands which contains lone pair and which is capable of donating electron at a time to the central metal atom or ion is present in that. An example of that is ethylene diamine triacetate. And one of the very important example of polydentate ligand or type of polydentate ligand is hexadentate. Hexadentate means in that 6 donor atoms are present, and example of that is ethylene diamine tetraacetate, or its short form is EDT. So this EDTA structure is shown here. In that EDTA, you see here 4 oxygen atoms, here 1, 2, 3 and 4, and these 2 donor atoms are the donor atoms, and it donates their lone pair to the central atom, and so this is called as hexadentate ligand.